So today we're learning about different other ways of factoring. So the main way we factor quadratics is we have the trinomial factoring. And remember, trinomial, I don't know if we will go over it later, but back in the day, we used to teach you the name things. Trinomial means there's three terms. So there's an x squared, an x, and then a constant. That's very much sums it up. That's not. I don't want you to be like, actually, that's wrong, because it's not exactly, doesn't have all the information, but that's what we mean. So if there's three terms, that's the trinomial factor we've been doing. We did one with leading coefficients, without leading coefficients. So the next ones are other ways of factor. Now, some of these are going to be quadratic, some of them aren't going to be. The other lesson we're going to after the quiz is over sums and differences in cubes. So it's kind of a hodgepodge of factoring. So there are four different ones we're going to factor, four different ways. The first one is the greatest common factor. Hopefully you guys remember we've done the greatest common factor before. I've had a couple people that get a little bit confused at how I'm finding the greatest common factor. If you need to list out all the factors, please do so. Hopefully you don't have to, most of you won't. But again, that's one of those things that I would rather you take time and list those out and get them right than just go quickly and get those wrong. So before I start, there's two tips I give you with this, and these are actually not super helpful right now. They're going to be more helpful the last thing we do today. And the other thing before I start, I will tell you, a lot of students get confused since there's four different ways of factoring today, and that's not included the other fifth way of trinomial factoring. So a lot of students get really confused about, so when do I know what one to use? It's actually not too bad. With greatest common factor, honestly, I always check that first. So really, I know a lot of you guys won't, but most of the time, that's always the one you should check. See if you can take out a greatest common factor right from the beginning. There's some other to look for, but I just always check that first, and that's always what you should do. And again, we'll talk about the importance of that a little bit later. So between 4x squared and 6, we are taking out a greatest common factor. Now again, I've had students in the past, they literally look at that, and they don't have any idea how I came up with 2. So the greatest common factor between 4x squared and 6 is 2. They have no idea where they came from. If you need to, list the factors of 4, 2 and 2, factors of 6, 1 and 2 and 3. The biggest number that they both share is the greatest common factor. So the greatest common factor is 2. That's the biggest number. That is the factor of both of them. So that is how I came up with 2. Now, the variables we'll get into in a little bit. I honestly think the variables are easier. We'll talk about that in the next one. So we take out a 2, which means everything else is left in the parentheses. We'll talk about that in a second as well. So 4 divided by 2 is 2. We didn't do anything with the x squared. 6 divided by 2 is 3, so we're left with 3. So we end up with 2, and in parentheses, 2x squared plus 3. The reason that because I've had students that they take out the greatest common factor, they do everything correctly, but their all only is just the 2x squared plus 3. That's all they have for their answer. The reason is because factoring is doing the opposite of multiplying. So everything you've done so far, if you want to actually check your work really rigorously, it takes some time. But you can use the distribution or foiling, whatever you want to call it, to take your two binomials and multiply them together to see if you end up with what you started with for your answer. Same thing with this one. This one's a little quicker. That's why I'm bringing it up now. I can make sure I'm right by just distributing this. 2 times 2 squared is 4x squared. 2 times 3 is 6. So that's why you need the parentheses. That's why you need the 2 up front. Because again, you're just kind of doing the opposite of multiplying. You're just kind of breaking it up. So the next one, again, we look at it two separate things. We look at the 12, 18, and the 6 separately than the variables. We'll get onto that in a second. You need to, you can list them out. For this one, you need all 3 of them. So we would have 12 is 1, 12, 2, 6, 3, 4. 18 is 1, 18, 2, 9, 3, 6. And 6 is 1, 6, 2, 3. And again, I went kind of quickly through that. Most of you guys don't need to do that, or a lot of you guys won't need to. But again, if you do need to, if you can't figure it out, definitely pick that. It might be beneficial because I've seen a lot of people that pick 2 for this one. Well, 2 is close, not quite there. A lot of people pick 3. That's honestly kind of what I thought right off the bat. but the greatest common factor is 6 for all of those. Take out a 6, the numbers. Now what about your variables? Now the variables are actually really nice because you just look at all your variables, and whichever one has the smallest exponent, that's what you take out. So my smallest exponent is an exponent of 2, so that's what I take out. So now what do you have left? Once you take x squared, 12 divided by 6 is 2. I have 3 x's, and then so I have 1 left. That's I have other ways of describing it. I've heard other people talk about different things, and I think the easiest way to look at it is x to the third is x times x times x. So if we take out x squared, we take out x times x. We take out 2 of those x's, we have 1 left. I think that's the easiest way to think about it. 18 divided by 6 is 3. I have 4 x's. I took 2 of them out, so I still have 2 left. And 6 divided by 6 is 1. I have 2 x's. I took both of them out, so I don't have any x's left. Now, again, we'll talk about this a little bit later, but what you always do is double check, is there anything else you can factor? There are some questions that we'll get to at the very end that are a little bit more where you are going to have to factor all over again with whatever's left in the parentheses, but also it's a good way to check your work. Because a lot of students, like I said, if you would have taken out 3 instead of 6, you'd still be able to take out a greatest common factor with what's left. So that's why it's a good idea to double check that. With the exponents or with the variables, it's actually really nice because if you just want to take a really quick look, if any of these terms, or sorry, I should say, if all terms have an x, then you can at least take out 1 more x. So there should be some term that don't have any variables, because if there is, or if there's not, you can at least take 1 more x out. That's what you get for this one. So I can't give you a ton of time on these, mainly because we don't have a ton of time, but go ahead and do number 3 and 4 on your own. I'll put up the answers here in a second. All right, moving on, because we don't have a lot of time. The next factoring. Well, whatever. We're going to start. I never know if that's the minute bell or the next bell. Anyways, we're going to do it. So the next factor is factor by grouping, and this one I really like because it's very obvious. They're the ones that have 4 terms. So you have 3 terms is one that look like this. 4 terms, we have this 4th one here. Every time we have 4 terms, that's what we're using, factor by grouping. I was excited, started doing it early. I apologize. So, by grouping. Called factor by grouping is because we have them in 2 separate groups. Group it into the first group and the second group. My first tip, second group, that first sign, I always keep that in the parentheses. If it's a plus, you don't actually have to. But if it's a minus, you do have to, or you're going to miss stuff. Always, whatever that sign is, just keep with that 9. And then I add my own plus sign. I'll be honest with you, you don't have to add that sign. If you don't add it, it's probably not that big of a deal. I always add it because, as a math person, I lose sleep at night because technically it's not multiplication, it should be adding, so I put it there because that's what I have to do to feel better about myself. But it is adding, so I add that plus there. So really, it's this group plus this group. Once you have that, then what you do is you do the greatest common factor that we just did. We're just doing it for each one of those groups. So the first group, I take out a between the 3x to the third and the 4x squared. You take out an x squared. 3x minus 4. Again, that part is the exact same we just did before this. And look at the second group and do the same thing. Between the 9 and the 12, I can take out a 3, a positive 3. 9 divided by 3 is 3. The x doesn't change. 12 divided by 3 is 4. X minus 4. Now, it is not an accident that these 2 parentheses are the exact same. Everything, the numbers, the variables, the signs, everything's the same. So once you get to this, I really like this because that's a good way to check your work. If those are different, you did something wrong. So go back and look at that if you need to. So to put these together for your final answer, in parentheses, put together. So x squared plus 3 goes together in their parentheses. Are the exact same, go together in one set. So 4. It doesn't matter which order you have those in. Our parentheses go together. Everything that is as one. Now, if you just memorize that, that's fine, but I'm going to take about 10 seconds to tell you why that is or why that works, because I think that kind of helps some students understand. If you work backwards and take the x squared plus 3 multiplied, you take x squared plus 3 times 3x. Or sorry, x squared times 3x, x squared times negative 4. Well, if you go up here, it's the same thing. X squared times 3x, x squared times negative 4. And then you go back to the 3x, the 3, you distribute that, just like the 3 is distributed here. So you can see, well, not lag. So you can see where those are all distributed. This x squared would go to the 3x and the negative 4, just like here. The 3 would go to the 4, just like here. And so that's why you can do that. Now, again, if that doesn't make any sense or that's confusing, you don't actually have to know that, as long as you understand everything that's different, that's not in parentheses, goes together. The other two things that are in parentheses, if they're the same, you put in one spot. You just kind of combine them or overlap them or however you want to think about it. That's how you get your answer. Now, the next one, we do the same thing. We do our parentheses. Again, that sign has to stay with the 30, especially in this one because that's a minus. And the next one, the next tip I want to say, if the second group starts with a negative, you want to factor out a negative. So the first group, everything is the same. I'm going to factor out a 2x squared. That leaves me 6x plus 1. Then the other one, if you don't factor out a negative, you will not have the same in both your parentheses. Now, when I used to teach this at the very beginning, my first, second, third year teaching, I would try to avoid that, but this is the easiest way. If you ever have this, ever starts with a negative, you're always going to factor out a negative. That's the easiest way to remember it. Once I figured that out, it was way easier. So that is a negative 30. So I'm going to factor out a negative 5. So negative 30 minus negative 30 divided by negative 5 is positive 6. Negative 5 divided by negative 5 is positive 1. And now you can see those parentheses are the same. Factor out a positive 5, the only difference will be that the parentheses will be the exact same. It's just that this will be a negative 6 minus 1 compared to positives. So now that you got to that point, the rest of it should be pretty easy. We have 2x squared minus 5 and 6x plus 1. And the last example, tip 3, if you ever can't factor anything out, you need to factor out a 1. Now, normally speaking, if you go back to what we did in part A, where we took out a greatest common factor, every number has a factor of 1. Every number has a greatest factor of 1. So if you take out a 1, it doesn't really change anything. So normally you don't factor out a 1. However, with factor by grouping, you need to do that. And I'll show you why in a second. Hopefully it kind of makes sense. So again, same thing, we put those together. I got an 8x squared, so that leaves me with x minus 8. Can't take anything out, so you have to take out a positive 1. If you with nothing changes, you got 1, so nothing does anything, so it leaves x minus 8. When we put that together, 8x squared plus 1 and x minus 8. Not take out a 1. You end up with something that looks like this: 8x squared times x minus 8 plus x minus 8. And so you see those were the same. If you would try to put those together, you can. Again, you're missing something. So if you were to work backwards and multiply this out, 8x squared times x, 8x squared times negative 8, you don't get your answer at all. So this is one of the rare times you need to factor out a 1. If you can factor anything else out, you need to factor out a 1. Placeholder. You need something in that spot to represent that. So go ahead and do number 8 and 9 on your own. Again, I'll put the answers up here in a second. I don't want to rush you, but again, I want to make sure we finish during this class period. To rush you through this, but those are the answers I got. The biggest thing, that 28 starts with a negative, and so you have to factor out a negative. So I factored out a -7. And again, the thing that I really like about factor by grouping, I actually used to use factor by grouping to teach people trinomials as well. And the main reason I did that is because it's really nice to have kind of a way inside to check your work. If these aren't the same, you did something wrong. So that's always something you can double check. And again, hopefully you don't even need to double check. Hopefully it's pretty obvious. You can't combine them if they're different things. Okay. Moving on, the next thing is difference in squares. So far, common factor, I always say you should look at that first anyways, no matter what. You should check that. The other way, the greatest common factor is if none of the other factoring methods work, you can use greatest common factor, or you should check that. Factor by grouping has 4 terms. Difference in squares is one of my favorites because the name is what it is. You use it when you have a difference, subtraction, in 2 squares. I put the formula, put this on yours, honestly, because a lot of people don't use that formula. But then I thought, you know, it does help. This is the formula I use. I also put that formula in an if-then statement because, first off, that's a little glimpse into what geometry is going to be like, so they really live. But also a lot of students get confused that this part of my equation, this first part, is telling you how to find the A and B and telling you if this qualifies. So I've had students that they try to do this equation, but they try to make the whole equation. Well, no, your answer is just going to be this part. And what this is your A and B. You can use that A and B to put this as our answer. So, people forget that it's got to be subtraction and perfect squares. So, my A for this one, I always tell myself, what number squared or what squared is x squared? Well, that's x. X is x squared. That is fine. If you ever aren't sure, you could ask yourself what number multiplied by itself is 25, or you can always take the square root. That A and B, then just put it into this part of your equation. X plus 5 and x minus 5. It actually doesn't matter. Your x minus 5 could come first. That part doesn't matter. But that's why a lot of people don't actually need the equation, because once you find your A and B, it's just A plus B, A minus B. What number squared is 49? W squared? Well, take it in 2 parts. What number squared is 49? That's 7. What squared is W squared? W. So 7. Your B, whoops. What is 6? That's 6. So 7W plus 6 and 7W minus 6. Now, the last one is what gets a lot of people, because the last one, a lot of people put x plus 4 and x minus 4. Unfortunately, that's not right, because they are perfect squares, but it's plus. If it is plus, you can't do this. We can't factor that one at all. If you ever can't factor, that is prime. Factor 5, you can't write down the factors of 5, only one. That's a prime number. Same thing with this. That ends up being prime, so you can't factor that at all. All right, go ahead and look at number 13, 14 on your own. Just like before, I'll give you a little bit. These two should go fairly quickly. and then we'll finish up. All right, both my answers are up there. One of the most common mistakes in this one is people going too quickly. For like number 13 for B, they put 81 instead of 9. So x plus 81, x minus 81. And they just forget to do the what number squared is 81, or take the square of 81. So just be careful with that. Make sure you're going slowly. Any questions on the... So the last one isn't really a factoring method. It's just ones we need some practice with. So from part A, I told you, number one is you ask yourself, can I factor anything else, or can I factor out of GCF? And your second thing, you should always double check to see if you can factor anything else out. I will tell you, just like I said earlier when I said I have to put that add-in sign, and it's not super important, but as a math person, I feel like I have to, or else it's multiplying, and that makes me feel weird. A lot of times you have a question like this, I'll give you hints. A lot of times the instructions say factor completely. And the reason for that is because if you just factor out of 3, technically that is factoring. So if I just told you to factor this one and you factored out of 3, I count you on for that in good faith because you did factor. That's why I need to say factor completely, because you can factor after that. So if I say factor completely and all you use you take out of 3, you didn't factor completely. There's still more factoring you can do. A lot of times, or sometimes, the instructions will give you a little hint with these, and they'll say factor completely. However, the problem is, I guess I should say they always say that. Look at your worksheet. At the top of your worksheet, it just says factor completely. So you have 12 factoring problems, and you don't know which one is like this. And I said factor completely on all of them, so all of them you need to make sure you're checking. So that's the double-edged sword. The good news is I would not lose sleep over this, because even if you factor 3 for number 15 and you leave it, you'll still get a lot of partial credit. So don't lose sleep over this. And there's a ton of these on the quiz. But the punchline is you can factor out a greatest common factor, like day out of 3. That leaves me with x squared plus 6x plus 8. And the last thing, is there anything else you can factor? So if you look at what I have left, can I factor that? And in this case, yes, factors of 8 that add up to be 6 are 2 and 4. So this is x plus 2, x plus 4. The 3 doesn't multiply by this, it's still 3 multiplied by the rest. That is what we're talking about this. So if I say factor completely, a lot of times that means you can factor something, and whatever you have left, you can factor that again. Okay, like I said, the double-edged sword on your homework, it just says at the top, so all of them, you should double check that. But occasionally on a test or a quiz, sometimes it says that for the exact question, which makes it a little bit more obvious, hopefully. Number 16, same thing. If you look at this, especially this, I mean, you can factor out the greatest common factor, but it only has 3 terms, so it's not difference in squares. It's not factor by grouping. If you try to do the trinomial factoring, we have an x to the 3rd, not an x squared, so we couldn't do that. So hopefully, by default, you realize you can at least take out an x. This one you can actually take out a 2 as well. So that means we have x squared plus 8x plus 15. And again, factors of 15 that add up to be 8. That does exist. That is 3 and 5. Don't forget about the 2x. Last but not least, it also works with a difference in squares. If you look at number 17, that's not a difference in squares. It is a difference, and it's a binomial. There's 2 terms. They're not perfect squares. But if you notice, you can take out a greatest common factor of 2. That leaves x squared minus 36. Now, all of a sudden, that is a difference in squares. My a is x. My b is 6. So it's x plus 6. X plus 6, x minus 6, and then don't forget that 2. Now again, don't lose sleep over this. Honestly, if I were you, the biggest thing I would do is before you hand the test in or the quiz in, if you have any extra time, just look at your vacuum problems and ask that. Can I factor out anything from here? Can I factor out anything from here? Can I factor out? Most of them will be very obviously no, and you won't have to do a lot of legwork. But it's not a bad idea to go ahead and look at that. Any questions before we move on? Or before I let you guys start working on your worksheet and or homework checks? All right, tomorrow's a review. We'll go over a lot of this factoring stuff. Then Friday is our quiz.